So, we are going to attempt to square away, finish off yesterday's lecture material. We'll try to move through it so that you guys can get to your lab as soon as possible. I don't care about the news. All right. So, this is approximately where we left off. So, there. Oh, I hate it. Microsoft, that's an easy fix. That's an easy fix, Microsoft. Why, when you enter presentation mode, don't you enter presentation mode on the slide you're on? Why? Why is that not a thing? Come on.
There's actually a key button to do that.
There is a key button to do that?
Yeah.
Why isn't it the default?
I think it's the button right next to it.
Oh, okay. But still, that's even more confusing. All right. It's not my fault, it's Microsoft's fault. So, I would like to take like 5 minutes to explain to you like how software like SQL comes about, right? So, you may have noticed that there's a really large number of SQL engines, right? We went through the list like yesterday in class, but if you scroll down to the bottom of that list, you'll find that website tracks close to 400 individual software packages which implement databases or are database management systems, right? Why? Why are there so many? How is it that there are so many? So, this is the way that software used to be done back in the 70s and 80s, prior to the open source movement. You guys know what the open source movement is? You guys know open source software? Hands up if you do. Hands up if you don't. So, the idea behind open source software is that you take the source code for your stuff and you release the copyright on it. You publish it publicly on the internet and you say, okay, anybody who wants to take this, modify it, whatever, go for it. Normally, there are only a couple of restrictions on open source software, such as you can't take something that was released open source and then turn around and start charging money for it. Also, if you publish further versions of the software, it must be released under the same type of licensing that it was given to you under, right? So it's not like open source software doesn't have any restrictions at all, right? It does have some degree of licensing, but the licensing tends to be, for the purposes of distribution and sharing and being nice people, right? So, back in the 70s and 80s, open source software did not exist. So the way that these things typically worked, you would have some brain box at some company like Bell Labs or IBM or something come up with a specification for a language. You'd have a great big document specifying how a language was to be implemented, what features it was to have. The C programming language originated the same way. Then, this company licenses the specification to other companies. They pay for the privilege of producing an implementation. So, Oracle, for example, released the first database management system, but SQL itself was developed at IBM, right? Oracle licensed the SQL specification from IBM, paid money for it. Now, under that model, there's no reason you can't license your language to multiple other companies, right? So companies do that. So what's the differentiating thing? Well, basically, companies take advantage of parts of the specification that are vague, that don't completely hammer down what the language is how the language is supposed to behave in certain cases, but most particularly, they add features, right? In SQL's case, a lot of features were added. This is why you have such a plethora of different SQL packages that are so old, right? Each one has a slightly different feature set that's tuned to slightly different problems, so that's how these companies like Oracle that were selling databases were saying to people, listen, you want ours versus that guy's, because ours does this fancy feature, right? You can kind of feel how this is very 1970s, 80s capitalism kind of feeling, right? Since this, most of these specifications have been released open source, therefore open source implementations of SQL have become popular, not only possible, but very popular, because they tend to be free, because it's open source, free software. So, that's kind of that's how this software worked, and still works to this day. As I said, the same thing happened with the C programming language, which resulted in the three primary C compilers. You have GCC, which is the one that Linux, Unix uses. You have Clang, which IBM develops. C-Lang, but everybody calls it Clang, because that's just fun. And then you have the Windows C compiler. Of these three C compilers, only two of them are actually compliant with the C specification. I'll let you guess which one the one that isn't is. Yeah, it's Windows. The Windows C compiler isn't compliant with the C spec. That's okay. So, the system catalog. Definition. I love when the definition says definition, eh? A detailed system data dictionary that describes all objects in the database. So, I'm getting from this that the system catalog is the data dictionary. A detailed data dictionary, but the data dictionary should already be detailed. So, to me, this means synonym for data dictionary. The system catalog, also known as there you go, it is a synonym. Metadata, the data dictionary, system tables, SQL Server, or the system dictionary. Depending on what system you're using, you might be encountering any of these terms. Although I would say that metadata is probably a subset of the data contained in the data dictionary rather than the data dictionary itself, but you know, so it goes. Starting with SQL Server 2005. Oh man, do you guys remember? A lot of you guys weren't even born in 2005. How many people were born in 2005? Wow. Well, not in, but yeah, in or before. Yes. How many people were born on or before 2005? All right. The rest of you are since 2005. So this is like this thing that it's talking about is actually older than you are, a lot of you. System tables are hidden and not directly accessible. A large collection of system views have been created to accommodate accessing of the database's metadata. You either have information schema or SIS. These are things that you can look at in information schema. Information schema, you can think of it as an object which tracks data about the database that you're working with. Things like, what tables are there in the database? Surprisingly useful to know. What columns are there in the tables in the database? What rows are there? Well, actually those are just entries. Constraints. Constraints are another important one. We'll be talking about those a bit later as well. But you can see there's quite a lot of information that you can get about the tables and the construction of your database. Any questions so far? Yes, no, maybe? The sys schema, sys stands for system, by the way. The sys schema is more exhaustive than information schema. However, it is more complex and not as nice to work with. So you should probably use the other one. All right. Let's talk about making tables then. So, the keyword to create a table is create table. Uh-oh. You then have to select a table name. This is there are a lot of parallels to declaring a function, although, you know, a table is not a function. Well, a table kind of is a function in the sets theory sense, but it's not a function in like the programming language sense. So it is kind of like, anyway, it's not that important. So it's possible that you folks have never seen notation like this, so let me explain the notation. Does anybody know what it means for something to be in square braces?
Optional?
Optional, that's right. So when we say column name 1, data type, size, size is optional. Size is optional because size only applies to specific data types. Varchar is going to be our data type for strings. It's a string where you specify what the length of the string is, right? In that case, you have to specify what the size of the varchar is, but you don't have to do so with integers or booleans. The size is implied. Does that make sense? You can also say whether or not you're allowing null values in the column. In other database systems, the required keyword also serves this purpose. If a field is required, then it can't be null. Also, if a field is not null, it can't be null. That's a little more explicit. Does that make sense? Another option is that you can set a default value. So if you're not permitting things to be null, you can assign a secondary default value. 0 is a good example in the case of the integers, right? Because essentially, when you have an incoming SQL query, it kind of provides the data it provides, and you either accept or reject the whole query. You can't partially execute a query, right? Queries are atomic, right? So queries are, quote unquote, atomic transactions. This means that they either execute completely, in whole, or not at all. Does that make sense? So far, so good? Okie dokie. So you can set a default value using the default keyword. Both of those are optional. You can also optionally set constraints. So, for example, let's assume that you have, in our patients table, we have the gender column, which can only have one of 3 string values. Here, we can set a constraint so that only data conforming to that restriction is allowed in the table. Does that make sense? So we can set up constraints ahead of time. Another good example is, maybe your integer can't be negative, right? You can set a constraint saying, check to make sure that the integer is not negative before you process that query. Make sense? We are working under the assumption that pretty much every table we ever make should have a primary key. That is why the primary key constraint is not given as optional here. It does not have square braces. So, we need to say what column our primary key is. And if you need to set more than one primary key, you can do so. I think this is a syntax error. There should be a closing brace right there. There are additional constraints that you can place on columns to tell SQL Server which ones are foreign keys. You remember our cheese and crackers example from yesterday. You can tell it what column is a foreign key, what table and column it is a foreign key of, right? Yes, and then on delete restrict, on update restrict, we will see what those are for a bit later. So, tables can be created interactively by right-clicking on tables and selecting new table. You fill in the data from there. Examples follow on the next few slides. Tables can be created also in a script. So, essentially, if you take this and you produce an SQL query, written down query, that also creates the table. When creating in script, constraints, primary key, check, foreign key, can be specified in line or at the end of the statement. So, if you're working in raw SQL, you can do all of the SQL, you can code it like it's code, right? Otherwise, you're stuck using the wizard. Shall we create a table then? All right.
Absolutely not.
Absolutely not. I'm going to do it anyway. All right. If you haven't done so already, please get SQL Server up and running. Okay, I'm not sure I'm not sure what it's supposed to be, but to me it kind of looks like a little wireframe bird. Yeah?
It could also be like a flat piece of paper being rolled over.
Yeah. It's like one of those hyperdimension twisted objects. Yeah. Have you guys ever seen a Klein model? Okay, you guys know what a Mobius strip is, right?
Yes. I love knowing images.
Yeah. So a Mobius strip is an object where it only has one dimension, because if you travel along the inside surface of it, it wraps around so that then you travel along the outside surface of it. One of the tracks in Mario Kart 8 is actually a Mobius strip. Klein bottle is kind of fun as well. This is a Klein bottle. So a Klein bottle is basically the same idea, but with a two-dimensional, or like a surface. So the outside of the Klein bottle, if you were to travel along it, you travel along into the inside of the bottle, and then, you know, you can wrap around on a surface rather than just on a line, which is kind of cool. Anyway, are you loaded? Did you decide to load? Okay, good. Are you going to connect?
So you're gonna have to reset it again. I had to go through like 3 times for my server to connect.
Okay.
SQL Server County support staff as well, we're all sponsored today.
Like, shut the whole thing down?
No, so like like the cloud page or
Yeah.
like the player, you have to remove it like completely. So stop it and then remove it and then relaunch it again.
Okay. Yeah,
I
okay.
did that like 4 times and it didn't work. So. It's working out.
Yay! Hands up if it's working. Hands up if it's not working.
I'm not there yet.
Keep trying.
Thank you. I don't even use the cloud feature because I have multiple.
Yeah. Stealing with hatred. It would be so much easier to do this in SQLite.
Do they have it installed on the cloud computer?
What, SQLite?
Yeah.
No, but you can, it's just an executable, you can just download it. Hey, I connected. Alright. Databases. Oh, CHDB is in here actually. Alright. You know what though, I'm gonna make a new database. New database, we're gonna call you, examples. That's good. Examples, there we go. So I just made a new database called examples. It's gonna be a little bit different from our pre-baked hospital database. It doesn't have any values in it, but I'm just gonna, it's just for playing with. So, let's make a new table. New table. New table. Everybody see? Everybody follow along? I'm sorry, I don't think I can increase the magnification on the menus. I can try though. Can I? Window, view, full screen. Yeah, I actually can't increase the magnification. I apologize. Yeah?
You could try maybe just in Windows settings, let bumping up the scale for the slide.
Oh, yeah, that's true. Let's knock that down.
There's also a scale setting just above it as well.
There. Is that better? Okay. Oh, this is a separate instance. There we go. All right. So, I am making a new table. Oh, I'm sorry. What the heck? Get out of So, I am going to make a column, cheese ID,
We're back.
data type, well, we're going to make that an integer. There we go. Int, not permitted to be null. We shall make cheese name. That will be a varchar. 50 is fine. Name cannot be null. That's probably good enough. And of course, because this is in like Microsoft thinking land, you don't get to name the table until you click save. But the name of our table shall be cheeses. Cheeses. There we go. Very good. Make sense? Let's make another one. You can see there we go. Let's make a new one. New table. Column name cracker ID. Data type int. No nulls permitted, thank you. Cracker name varchar 50 is fine. Nulls, no thank you. Save this table. This shall be our table of crackers. There we go. Now, that's all well and good, but that is a very, very, like, DBMS bound way of doing it. I'd kind of like to do it in an actual SQL query for you guys, because that will be a lot more cross-platform. Shall we? Good. So let's make a new query. This I think I can increase magnification. There we go. So, what was our keyword? Create table. What did we call it before? Tries? Oh, yeah. Tasted. How about tasted? So, create table tasted. The next thing that we do, if we go back to our query itself, we must provide a schema. Just trying to decide how I want to format it. Try ID. Data type shall be int. Some of you who've never had a class with me will perhaps find the way that I do my braces a little bit funny, but know this. If you do your braces the way I do my braces, you make a line out of them with commas in between. First, I find that very visually appealing. It's like, it's nice, it's fancy code, pretty printed. Second, you'll never forget a comma, because they always start the line. You're never wondering or worrying, do I need a comma, do I not need a comma? As long as you don't put something here, because that's obviously wrong. So, we then had We need a cheese ID, which shall also be an integer. We'll need a cracker ID, which will also be an integer. And we will need a rating, which will also be an integer. So, in terms of raw data, this query is complete and would work. Right? We could execute that. Create the table. Actually, let's do that. Don't take my word for it. Execute. Command completed successfully. There you go. How do I actually view them though?
You have to refresh it on the tables.
That button? Refresh, refresh.
Right click on the tables, drop down. And then refresh.
Really? Wow. So, I hate everything. All right. You can see that cheese, crackers, and tasted all exist. If we create a new query, select star from tasted, execute that. There you go. You can see that we have all of our columns, but no data. Right? Makes sense? So far, so good? However, it's useful to add some constraints. So, let me now show you another query, which is the query that you use to remove a table. Anybody know it already?
Drop table.
Drop table. Drop table, table name, in this case, tasted. I do not have permission. What do you mean I don't have permission? I have permission. It just executed successfully. What are you talking about, Microsoft? It's gone. I don't have permission. All right. So, first things first, let's make our try ID into a primary key. So, constraints, you should think about them in the same way that you think about basically any other form of error checking. Your database will work without them, right? Like you could get the database to be functional just using this for your schema, but it's not preferred, right? You need to have a little bit of error checking because an idiot might try to use your database at some point. That idiot might even be you. So, yeah. So, let's set this guy up as a primary key. So, constraints. Try PK. primary key. Why would I think an underscore went in there? There we go. So, you might think it's a little bit strange that we're entering constraints in kind of like they are their own columns. But here's the thing, folks. They are. A lot of the time when you create these constraints, additional metadata has to be kept in the database to make sure that the constraints are true, right? This requires additional memory to be allocated to the table. So in a very real sense, that is actually a table, a column that you're adding to the table. The only thing is, it's a hidden column, right? You're not supposed to really have direct access to it. Does that make sense? Okay. So, let's execute this. Command executed successfully. There we go. And there we go. You can see that that column doesn't appear, but we still have a thing with nothing in it. So let's add another statement down here to insert something into the table so that we have a little bit of data to work with. Insert query. Insert into tasted, or yeah, tasted values there you go. You can confirm that try ID is now a primary key because you get the little key icon. So, cheese ID, let's say 2, 3, and -2. Let's drop the table and recreate the table. There we go. Aha! Column name or number of supply values does not match table definition. So, we're missing something. We have to say what columns we are assigning to, and in what order. Cheese ID, cracker ID, and rating. I know MySQL wants backticks for this. It seems that, you want regular ones? Yeah, okay. MySQL wants backticks for this. It seems, this guy wants regular ticks. All right, execute. Invalid column. You want ticks at all? Drop the table. Execute. Okay, well, I've perhaps overstepped what the slides were saying anyways, and you guys have a lab to get to. We have slides a little further on about insert queries and all of that, so let's shelve that for the moment and keep going with this. So. Okay. So. We've done interactive table creation. Yes, 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 yes. So. It is useful to see how you set primary IDs and that sort of thing when creating tables. So let's destroy our cheese. Oop, wait, that was wrong. Oh well. Let's destroy our cheese table. Create a new one again. There we go. Cheese ID data type int. Null is not permitted. And then cheese name type varchar. Null again not permitted. If you highlight the row and then right click, you can see that you have some additional options for things you can do with it. So for example, set primary key. That's now the primary key. Relationships. Interesting. Check constraints. Add a constraint. Oh. Oh, what did I do? Wow. So, let's say that the cheese itself had a rating. And let's say that rating was between 0 and 10. And you can optionally not have a rating. Check constraints, add constraint, expression, let's see here. Rating is greater than 0, greater than or equal to 0, and rating is less than or equal to 10. There you go. That's how you can add a constraint using table view. Make sense? Any questions? Yes?
Just go over that again, like how to create a restraint using.
Sure. So if you've got the row, the row in this table highlighted, you right-click, check constraints. You can then add or delete constraints. If you add one, there you go. You enter the expression that expresses what that constraint should be. The constraints need to be Booleans, or they need to be expressions which evaluate to a Boolean. Make sense? All good? All right.
So when you say it needs to be Boolean, like you literally just type true or false?
Well, I mean, a constraint that is either true or false would just globally enable or disable the ability to write things. What you need is something evaluating to a Boolean, like a comparator operator, right? This must be greater than that, this and that must, this must be in this set of possible options. We'll see a couple in the slides. We can. Oh, like right here. Gender in FMO. That's another constraint that you could set, but that evaluates to a true or false. So when I say that it needs to be a Boolean, I mean it needs to be an expression which evaluates to a Boolean. There we go. So, yes, I think we've already demonstrated all of that. Here's an example of a script that you can use to create an employees table within the hospital database. You can see that for all of this stuff, this works pretty similarly to how we were doing it. Not null, you can specify. The constraints are fairly easy to plunk out as well. The name is something you get to choose. You will notice that the constraints are prepended with either PK, CK, or FK. These stand for primary key, foreign key, or check. It's like a naming convention thing. It's not required by the language. You specify which primary key. You use the keyword check and then specify basically the same expression that we were putting into that little dialog box, right? And with foreign key, you specify foreign key, you say what table and what column in that table, and then you reference it. Oh, okay. Okay, it's a little, there's an underscore character here which is hidden by the red squiggle. So watch out for that. So department ID, this is not a space, this is an underscore, so that is one identifier, right? So we're saying that department ID here is a foreign key, this column is a foreign key, and we're saying that it references the department's table and the department ID within the department's table. Please be careful that you understand that these two are two different names in two different tables. They don't have to be the same string. They don't have to be the same identifier, right? The fact is that most of the time when you're creating a foreign key, you will reuse the same name as the primary key in another table, right? It's natural to do so. But just understand that that's not like a constraint of the language, right? Those identifiers don't have to be the same. Does this make sense? Any questions? All right. Yes? You can also specify the primary key as an identity by using the identity keyword. Here are your data types. This is a subset of your data types. One of the things that varies across SQL vendors is the data type, but you should find, there's like a core set of data types that will be shared across all of them. All SQL databases have integers, booleans, dates. Money might be specific to SQL Server, right? SQL Server Express. Yeah. Those are your numeric types. These are your other types of types. Varchar is the one that we're going to be using a lot. Text might be deprecated in Microsoft Server Express, but in other SQL servers it may not be. So, text, like I've seen other places where text is used for string. So, yeah. Char versus varchar. Character array, variable character array. That's the difference between char and varchar. So a character array is of a fixed length. It always takes up the same amount of memory, no matter how many characters are used in it. The variable character array is a character array, but the length of it is determined by the content. So it doesn't waste as much space. Make sense? So that's why varchar is preferred, because it uses less memory overall. And you might think that that's kind of a trivial amount of memory to be saving, but when you have a database that contains, umpteen squintillion points of data, wasting 2 bytes umpteen squintillion times means that you're wasting, double umpteen squintillion cells in memory. Like, when it comes to databases, it actually does matter that you keep things as small as possible. Make sense? All good? Good. All right, null. All data types support the concept of null. Null is the absence of a value. It is unknown. Hopefully everybody knows what null is. For numeric columns, null is not 0, and for a string column, null is not an empty string. An empty string isn't an empty string anyways, it contains the null character, but, so it goes. Stare ye not into the null, lest the null stare back into ye. And we're done! Ha! Get to work on your labs. I suppose I should introduce the lab actually, shouldn't I? Maybe. Lab 1. Whoa. There's no thing. Yeah, okay, just, it's a quiz, it's a Canvas quiz, so go fill it out. Yes? Oh, question? Okay. Oh, wow. Give me a moment. Give me a hot moment. Okay, don't open it yet. Close it. I know. Give me a moment. Give me just a hot minute. The fact of the matter was, I was trying to do some updates to it.
I don't think you need to call it task manager and just destroy it. I'm rested because it's just lying to you. It's just lying to you. Every down with bar is lying to you. Always. Guys, you guys
Is it questions 11 through 14 that are the problem?
just give up. But people be just give up. I'm not gonna announce this. I give up.
All right. I hereby declare a 5-minute break. Go get yourselves a cup of coffee or something.
Free energy.
You think the line's that short?